Hello everybody, welcome to the Fall 2019 edition of Circuits and Codes, live from M5. Let's go check out some cool projects.
I'm Aaron. I'm a junior compy here at UMass.
Would you like to tell us a little bit about your project?
I mean, yeah, it's a pretty simple demonstration of how DES encryption works. It takes a 16-bit color BMP file, encrypts it and sends it to an image, and then decrypts it and sends it to an image.
So is the encryption sequential? Like it goes one pixel, then the other pixel? Okay.
One pixel at a time, yeah. So this actually isn't a very strong encryption algorithm. You can see in the first image we have patterns where there are patterns in the actual decrypted image, and that is because DES doesn't encrypt in a chain. It does it just one off on its own each time. You want to tell me about yourself and like what your project is?
Yeah, I'm Sai. I'm an electrical engineering major. In my junior right now. And then this project is a BCD clock that me and my team of UIAs help to help the freshman engineering class build for this semester.
How does it work exactly?
So there are like two parts in the circuit. The computer that generates a clock signal every minute, and then these are the three ICs that we use to run the LCDs and so that the clock forwards every minute.
You would beat all competition. Yeah. You don't want to miss out on that deal. This would be so good.
My name is Jack DeGuglielmo. I am a junior in computer engineering here at UMass, and what I have to present today is a Python script that parses Craigslist ads for cars, and it'll send you a text if it finds a listing that meets your criteria. Basically, I'm using the Beautiful Soup Python library to scrape Craigslist URLs for cars you're looking for. So I can go ahead and run it now, and you can see it loops through all listings on the URL you give it, and then you can put in parameters for things such as like price, title, year, and make and model. Oh, so there it is there, you can see, and I'll open it up. Basically, it has like the title of the listing and a URL you can click to go right to the listing.
My name's Otto. I'm BDIC studying audio technology engineering. So this first project, it's basically just a wavetable synthesizer that you can program by yelling at it or talking into it. Right now it's all programmable with MIDI sysx messages, but ultimately I have like a menu system that I'm working on that should be able to, I don't know, change the parameters on the fly. But so you can record like just any arbitrary. M5 is amazing, and it'll pick up the formant of your voice, and that clip is it's turned into a waveform and outputted. Moving on, over here I have a step sequencer that I built around the Texas Instruments CD4017, which is a decade counter. So it's a 10-step sequencer that I made last year that I intended for it to be wearable as a hat, but it ended up being much too large. So instead I made parts of it that are wearable, such as this speaker bag, patent pending. It's basically, it just is able to modulate, or it sends out a variable voltage which you can feed into any voltage controlled oscillator, such as a function generator, which I'm just using one that we have here at M5. But yeah, you can change the pitch per each step. You can switch the number of steps that you want. You can turn on and off steps. You can freeze it. All sorts of fun things. This is a pretty simple, just multi-mode MIDI controller that I built for a performance that I had over the summer. And there's multiple modes, which basically just scroll through different MIDI control values, which can be then mapped per page or whatever to different variables.
All right, we're here with Ansh. Ansh, can you tell us a little bit about yourself and the project you have at Circuits and Code today?
Okay, so I'm a junior CS student, and here are my projects. So I've got two projects. I've got a circuits project and I've got a code project. So for my circus project, I have a finger-worn sensor to help facilitate stroke patients in their rehabilitation. When a person suffers stroke, we have found that their motor skills reduce by a considerable amount, and there needs to be a significant amount of rehabilitation in that. But once that rehabilitation is done, there's no way to figure out how well did they respond to it in a natural environment. To do that, you need to monitor their movements in a natural setting. To do that, we developed this sensor which takes your accelerometer data and sends it over Bluetooth to your phone, which pushes it to a cloud. This enables people to monitor patients even when they are no longer in a clinical setting, which is useful because you care much more about how a patient responds in a natural environment than in a controlled one. For my second project, we wrote a resume parser, which basically tells you whether you have a resume that's targeted towards a tech field. So it tells you whether your resume is targeted towards AI, full stack, hardware, so on and so forth. So to do that, we basically take a PDF resume, we tokenize it, that is, we extract all the words out and clean it up into data structures, which are, in this case, were hash maps. Then we assign word embeddings to each word in the resume, which is basically a numerical representation of the word. And then we average all the embeddings that we get to get a resume representation. And then we feed a classifier. We tested out multiple, but ones that worked for us the best was a random forest classifier. And that classifier then gives you a distribution of what your resume is most likely to be targeted towards for, which you can then take as a representation of how much you're targeting a particular tech job. And you can use that to tune your resume in case you wanted to go for a particular job.
I'm Akshat. I'm a computer engineering freshman, and my project is a universal wireless switch. So basically what it is it's an AC relay with an Arduino and a Bluetooth module. I can communicate with the Arduino using my phone, and I made this so that I can turn my fan on without getting up. So let's go a bit forward. And yeah, I can just use this app to turn my fan on. Yeah, it's really useful. I'm a lazy person. I don't like to put in more effort than I have to, and this helps me live like that.
We're here with Chinema. Can you tell us a little bit about yourself and the project you have this year?
I was enlisted by members in MEM5 to do a cybersecurity project along with my partner Aaron. So he decided to do DES, and I decided to do some basic Wireshark analysis. So what I'm doing here is Wireshark is like a network analyzer. So I go and take the packets that are being communicated between the like server at, like, let's say YouTube and your computer here. So then I stop that transfer, and we see all the packets that are there, and there are a lot. So how do we sort through all of this? What we got to do is just kind of guesstimate. Can't really open all of them, so I already know which one I'm going to pick. It's going to be the one with the largest byte size. So we can go and then click the follow stream and then follow that stream, and it reveals itself in ASCII, and then we can analyze what's here in this like header stuff and find that it is a audio file. And from there we can save that data now as like an MP3 file. So I've saved the MP3 file as the file name under M, so I can go and hopefully I can play it, and boom. And that is it.
Okay, I'm Josh. I'm a CS major, and basically what we have here is we have a very old school computer. You know, it's tiny and modern, but this is comparable to what you'd find in the 80s, and I built it mostly from parts and some schematics I found around online and stuff, because, you know, I just thought it would be cool when I wanted to experiment with kind of these old chips and, like, writing assembly and stuff, which you don't get a lot of opportunity to do on modern hardware because there's, like, no point. But I've got it hooked up to some LEDs here so I can give you something slightly exciting to look at. But yeah, if we look here, I can try and show you. This is our kind of serial console thing. So this is the actual program that I am about to show you. You know, it's just going to kind of count down in binary, and it's going to display the results on the LEDs. It kind of looks like, I can try and get it out here so you can actually see. It's going to look like this. Yeah, it's probably not the most interesting thing you've seen today, but, you know, I had fun with it, which I guess is the important thing.
Awesome.
Hello, my name's Ehan. I am a senior. I'm studying applied physics with an interest and concentration in electrical engineering. So the first thing we have here is our robotic squirrel, or at least the process of the robotic squirrel. So we have this really, really fat Adafruit feather stack. We can start off by getting the system off. So we use this beautiful switch here. It turns everything on. See the little squirrel that's in there. So now, if you notice, by the way, I am off the internet. I'm off the Wi-Fi, and I am still able to communicate wirelessly with this device. So if I do robot display hide all, you'll see there that everything vanishes, and then I can bring it all back. Also with the robot too, I can do a lot of different diagnostic testing, so I can get the voltage going through the system. I can also get the temperature that's in here too. Right now we're in the stage of just having the main module working. What we plan to do is adding more servos that can allow for movement here. If I want to shut down the system, that works too. Shut down. That's kind of the making of this one project here. I hope by next semester we'll have it in taxidermy so it will really look like a squirrel. I won't want to do that part though, because that's sad. Teardrop. So the next thing I'm working on is for my research lab in school. This is a drug screening neural network. So the point of this neural network is that it'll scan these 1024 long chemical fingerprints, which are just different bits that determine the chemical structure. So all on here, we have these different targets, and some of these are unknown. So then after it goes through several iterations, it'll finish up and then provide us with results. And this number here, if you want to zoom in, this number represents the accuracy that we have. And with 100% accuracy, these are the 4 that have been filled in. So we would assume this is active, and then not active, not active, active. And then finally, we have the work I did in Hong Kong. So this is optical coherence tomography system using integrated waveguide spectrometer. Essentially, this is a modified Michelson interferometer, which has light sources that get split and recombine to create a new light packet, is the best way to think of it. And then with that, we can do some inverse Fourier transformation and image processing, and we get a really high resolution image of in vivo biological skin that shows depth values. And by adding more dimensions, like having a camera that can take 1,000 pictures, you're able to get a 3-dimensional image, such as the one you see here. So I was just responsible for a lot of the programming for it. I made the code that does the spectral analysis here, and then some image processing, and then lastly, a neural network that's able to optimize the best values so we can get really good results. That's essentially what I worked on. I wish there was more music stuff, so coming soon.
Here we have Ehan, and can you tell us a little bit about your project?
So I 3D print a heart, and I put a pulse sensor in the heart, and the idea is just when you put your finger on the sensor, it will light up according to your heartbeat.
What gave you some ideas for this project? What inspired you?
I just really love hearts, and I think it would be really cool to visualize your heartbeat. I had this idea a while back, and I finally had the chance to do it this semester.
Hello everybody, I'm here with the charming Jonah Murphy, and let's see what he has for us.
So last year, senior year of high school, I was really, and still am, into Star Trek The Next Generation, and I wanted to make a prop from the show, because I've always loved props and things from shows. So I decided to make a tricorder, Now, a tricorder is a handheld environmental scanner, where if someone on the Enterprise were to beam down to a planet, they'd bring one with them so they could sense things around them. And I made a functional one from scratch out of 3D printed case, circuit boards designed, and then software I wrote. So I have 9 PCBs, which are printed circuit boards, inside of this 3D printed enclosure, each of which has a cable connecting to another one, and they all come back to a microcontroller on the inside. And this is just so I can take sensor data from the board and put it on the screen, so it's an easy way to view sensor data about the world around you. So this software is a graphical user interface that I had to write from scratch in Python, and that same software works on touchscreens. So this is like a implementation of that software that's meant to emulate a smartphone. So each of these little squares are apps, and then you can press on an app to open it, and you can use functionality within it. And you can use this code, which is running on a microcontroller, to interface with hardware. And then you can use that to have a very low cost but easy to implement graphical user interface with hardware you design.
Hello everybody, we are here with the wonderful Chris, and he's going to show us what he has done for Circuits and Code.
Yeah, so we're going to start off with a interactive virtual spirograph. So I'm going to start that right now. It has a hardware component too right in front of me. So what you have here is basically 2 circles. The smaller circle is tracing the path of the larger circle at 2 different speeds, and using the trim pots on the breadboard you can change the relative speed of the circles, and you can also change the relative radius of them. So I'll demonstrate that. And then once I clear the board, you get an entirely different shape. And we've been playing with this for hours now and are still finding new shapes in here. So this has been a fun one for people to come up and play with. So this is my second project. It uses a webcam, Logitech webcam, and does some computer vision. It's actually color tracking right now, and it's tracking their phone screens, which are set to be green because we found that to be pretty visible. And they're playing a game of Pong by physically moving their phone screens. And you can see these little white circles are the feedback, which means that basically the camera's picking up that color. And their paddles can impart velocity onto the ball. Alright, so my third project is a little investigation into random walking. So this is a one-dimensional random walk, which means that this little circle is going to step either to the left or the right randomly with a 50-50 chance. And as it does so, we're going to animate it and watch its progress and basically see. This red line is the mean of where it's been, and these lines are the edges of the screen basically. And so studying random walks is something that we do in physics quite often. And this is just a cool little simulation so that you can watch it happen in real time. And that'll be the end of that walk. So all of my projects are done in Java. I use the processing IDE for pretty much everything I do. I like it a lot. And yeah.
So we're here back at M5 at Circuits and Code, and we have Karen, a local artist from Northampton, with some of her art pieces that have electronics in them. Karen, could you tell us a little bit about each of these, please?
So this project is the Leyden jar project, and it's a history of science project. The Leyden jar is the original form of a capacitor, and a capacitor stores energy in the glass between 2 pieces of metal. So I enlisted this poet, Cole Svensson, who teaches at Brown, to write poems having to do with different figures in the early history of electricity. So when you touch a jar and release it, the Leyden jar. It uses touch sense capacitance to register when you've touched a jar and released it, to then trigger to play a particular sound file. So this is letterpress printed a history of the Leyden jar from the early period up until, well, so I talk about Michael Faraday, well, first Benjamin Franklin and his experiments with the Leyden jar, which then led to his career as a diplomat. You know, he was a scientist. He was first a letterpress printer, then he was a scientist, and then that's how he made his way in French society, which enabled him to be our diplomat during the American Revolution. So if it hadn't been for the Leyden jar, we might not have won the war against the British. So this is the apothecary of amulets, and whereas the Lime Jar project uses touch sense capacitance to play the sound file, this uses a RFID tag. So there's one poem associated with each of the jars. So the poet refers to her poems as amulets. That's why we do amulets. And you put the jar
Imaginary
into the inner part of the sculpture and plays the sound file.
See leach power rankings registration season. Not all drivers participate in every burrowing.
This is the leech amulet. You can see there's a leech inside of it. It's not alive. It's not gonna suck your blood.
Do you have a lot of, or do you know a lot of fellow artists who use electronics in their work?
I really don't. Yeah, no. So it's really fun for me to come here and to meet other people.
Do you have any last things you want to say to the audience, or
To the audience,
notes on art?
Notes on art. Just keep making things. Keep exploring.
How's it going? We're like, you don't care about me at all, like at all? Oh shoot! Hold on. We're gonna have to cut that.
Furthermore, what type of modules did you? I broke character. Why?
You had a character. You're supposed to be yourself.